Hi, my name's Serenity.
Hi, my name's Emily.
Hi, I'm Kelly.
Hi, I'm Scarlett. And today we're going to talk to you about
Trigonometry.
What's trigonometry?
You know what trigonometry is?
No.
Okay, well, trigonometry is the branch of mathematics dealing with the relations of the sides and the angles of a triangle and with the relevant functions of any angles.
Oh, that sort of makes sense. So how do we use trigonometry? What do we use it in?
Did you know that trigonometry is used in the medical field?
No. How?
Yeah, trigonometry in the medical field is found in MRIs, breathing, heart rate, and ultrasounds.
Really?
Yeah.
How do you apply them?
Well, let's show you some examples. Emily and Scarlett, please come in.
Scarlett isn't here yet. Do I still go in?
Yeah, that's fine. Just come on. Step into my office, please. Take a seat. Okay, so are you ready to check your heart rate?
Wait, no needles, right?
No. We're going to use this equation to check your heart rate without needles, okay? And this lovely little monitor here will do this equation for you without needles. Okay, so if I can just have your arm here. Thank you. And don't cross your feet. And this will be painless without needles. As you can see, this is the equation that I had on my wall that is checking her pulse per minute for her heart rate. Checks out that your heart rate is 57 beats per minute. You're good. Now did that hurt?
Yes, a little.
I'm here. Okay, let's get started. Okay, Scarlett, we're done. We're done.
Okay.
Bye.
Bye, Felicia.
But I'm Serenity. Okay, so for heart rate, we have this equation, y equals a of cos of bx minus c plus d. And so for our a, we know that a equals amp, and your b is a period of 2 pi. But keep in mind that your period can differ due to movement. So for example, it can differ if you're sleeping versus if you are running. And your c is your normal left and right shifts, and your d is your up and down shifts. We also have to keep in mind for C and D that they're not always going to be constant because they can change due to factors in your health habits or in your weight or in your sleeping patterns or any other factors. So let's take a look at Emily and Scarlett's heart rate. So for Emily, we have a normal heart rate of an amplitude of 4, and she's not really moving a lot. We know that she was at rest. Okay, and then we have Scarlett, and at the beginning of the heart rate graph, you can tell that it is, obviously her heart rate is very rapid, and then over time when she begins to relax, it decreased in the rapidness. So from the graph, we can infer that Scarlett was obviously doing some sort of activity here, and then she began to rest, causing her heart rate to slow back down to normal.
If you're having an allergic reaction, everything's gonna be okay. We're gonna figure out your breathing rate, okay? With this monitor, we're gonna find out the rate of her breathing, and we're gonna be using this equation. This equation is gonna show, obviously, her breathing rate, and the bottom one shows her lung capacity and how much air is actually in her lungs. Everything's gonna be okay, don't worry.
While Serenity was having an allergic reaction, she was holding onto a monitor calculating her breathing rate, and the monitor was able to calculate her breathing rate using this equation. I'm going to go ahead and explain what this equation means. We know that our A is known as amplitude. We know that sine is a graph that looks like this. The reason why we use sine to use with our breathing rate is because sine starts at 0 and it's a rhythmic pattern. We know that pi is 3.14, our p is our period, and t is time, while sy is our phase shift. There are certain portions into this equation that, I guess in a way, changes a person's breathing rate. And I'll go ahead and explain this. You know that A is an amplitude, and that affects the height of a graph. So let's say, for example, Serenity's normal breathing rate is something like this. For this instance, her amp was 2. Okay. While this part of the equation shows the height of a breathing rate, this side of the equation shows how quick the person is breathing. And let me show you an example. Let's just say that after a person completes a period of this graph, it was 2 seconds. So Serenity's breathing was as normal, 1 breath after 1 second, after 2 seconds. She was having 3 sessions of breaths per second. And that is how this monitor shows a person's breathing rate.
Hey Kelly, how can I help you today?
Hey doc, my head's been killing me. It's been hurting me for weeks and I absolutely have no idea what's going on.
Okay, I think we're gonna have to put you in an MRI. Come on. So it's okay. We're gonna find where the tumor is right now. So this is your head and you have the tumor right here. So using this formula, we're gonna find the location of the tumor. So you have, the scan says that the distance between here and here is 9, and then we have the 2 sides, which is 3 and 2, and this one here is sine B and this one is sine A. So using this equation, we're gonna find the location of your tumor. So we have S, which is 9, and we have sine A, and you have sine B, which is sine of 2, and that's over sine A plus sine B. So you have sine A, which is your 3, plus sine B, which is your 2, and then we're going to plug that into the calculator. So, 9. Your tumor is 0.0314, so basically your tumor is here. I'm sorry, honey, I'm just kidding. It's basically around here.